Okay, so today what we're going to do is we're going to be going over chapter 2, 1 through 4. So this is about half the chapter, and we basically just covered inequalities in this chapter. So what I want to do is I want to go over some question types that you might see on a potential quiz. So starting with question number 1, it says a number z minus 6 is greater than or equal to 11. What we want to do is we want to take this sentence and write it as an inequality. The number z is going to just translate down here to be the variable z. Minus is the same thing as subtraction. 6 is greater than or equal to. So is greater than or equal to is this symbol here. Notice how the bigger end is facing what is greater. And we want to say that's greater than or equal to 11. For the second one here, it says 12 is no more than. All right, so let's go ahead and write this right here. Okay, so what I want to do here is I'm actually going to go and put my chart that we've seen in several notes. I'm going to see if I can put that on the screen. Might not be able to do that. Let's see. There we go. So here is the chart that we've kind of been referring to this whole time. Let's go and take a look at no more than. No more than is basically another symbol for less than or equal to. So if something is no more than, we are going to write that as less than or equal to. So 12 is less than or equal to the sum. Sum means addition. The sum of negative 1.5 times a number w and 4. Let's write negative 1.5 times w, or negative 1.5 w. And it says the sum. So I want to say negative 1.5 times a number w and 4. A sum is addition, so I must be meaning plus 4. So that is something you're going to be responsible for, is taking a sentence and turning it into an inequality. Okay, let's keep on moving. Next part, write the inequality that represents the graph. Okay, so for this graph here, the important number is 0. That's where it's starting. We're going to the left, which means less than. So what we can say is that x, or whatever variable we have, is less than. Notice how it's not less than or equal to, because I see an open circle here. So x is less than 0. For number 4 here, our important number we're going to start on is 8. Notice how this dot is filled in. So what we're going to say is that 8 is, notice how we're going to the right here. This is going to be greater than, notice how there's an R in greater than, which means we're going to the right. This is going to be greater than or equal to, 8. In fact, one student pointed out to me that for inequalities, the sign actually always creates an arrow pointing the direction you should go. So notice how greater than points towards the right and less than points towards the left. All right, so let's keep on going. This is something that hopefully we understand. Let's move on to something a little harder. All right, so we're going to do one-step inequalities here. To solve these inequalities, we're going to solve them just like we would solve an equation. So what I'm going to do, I'm going to create a line here just so I kind of remember that I need, whatever I do to one side, I'm going to do to the other, just like in an equation. I want to solve Q, so what I'm going to do is I'm going to subtract 9 on both sides. I'm going to keep my inequality sign. 15 minus 9 is 6, and so Q, which looks like a 9 here, Q is less than or equal to 6. So what I'm going to do is I'm going to fill in a dot at 6, and I'm going to go to the left, less than. All right, for the second inequality here, this one's a little tricky because I see a double negative. If we remember in mathematics, a double negative actually equals a positive. So if I say z minus negative 7, that's the same thing as me saying z plus 7. And once again, I'm going to create this line just so I remember what I do to one side, I have to do to the other, is less than 5. Okay, so I'm going to go ahead and get rid of 7 by subtracting 7 on both sides. So I'm going to get z is less than negative 2. Okay, so I'm going to go ahead and draw an open dot at negative 2 because this is less than, not less than or equal to, and I'm going to go to the left of it. All right, let's keep on moving. Next question. All right, these are very similar once again, so I'm going to go ahead and create my line so I know that what I do to one side, I have to do to the other. This time y is on the other side. That's okay. Let's go ahead and solve it. I'm going to go ahead and add 4 to both sides. I'm going to get 1 is less than y. So even I kind of have a hard time interpreting what that means. So what I'm going to do is I'm going to flip this inequality. Notice how the big end of the inequality is facing y. I would prefer y be on this side. So I'm going to flip the inequality by keeping the big end of the inequality facing y and the small end facing 1. So y is greater than 1 is the answer here. I'm going to go ahead and create a big old circle, open circle at 1, and I'm going to go to the right of it. All right, the next inequality is super similar. I'm going to divide by 3 on both sides. I'm going to get p is greater than 6, greater than or equal to 6, which is going to look like this. So hopefully these are pretty self-explanatory. We're going to kind of move into some questions that maybe have different results. All right, so here we go. Let's go ahead and start this next one. I'm going to go and create a line so I remember what I do to one side, I must do to the other. W divide by -2. The opposite of division is multiplication. So I'm going to multiply by -2 on both sides. So I hope that this kind of reminds us to do something important here. If I multiply or divide by a negative in an inequality, I must flip my sign. So some students kind of came up with a memory trick here. I'm not sure how great it is. I like it. But negative multiplication or division means now I must switch. So we're going to go ahead and switch our sign. It's not going to be greater than anymore. It's going to be less than. That's what happens when you multiply or divide by a negative. -2 times 6 is -12. And this cancels to leave us just with W. Now, once again, I'm in a similar situation. I'm not sure what -12 is less than W means, so I'm going to flip it again. So I'm going to flip this so that W is on the other side. Notice how the big end is facing W, so the open end will face W, and the small end will face 12. So W is greater than -12 is the solution here, and that is what it looks on the number line. All right, let's move on to the next question. -20 times x is greater than 5. So notice how there is multiplication here. The opposite of multiplication is division. So I'm going to divide by -20. -20 divided by -20 is 1. But notice here, once again, I divided by a negative, which means that I need to do that special trick. If I divide or multiply by a negative ever, I need to flip my inequality. That is so important to remember. So I'm going to flip the inequality. It's not going to be greater than now. It will now be less than. So the -20s cancel on the left, leaving me with x. 5 divided by -20. Well, I know 5 goes into 24 times. So if I divide the top and bottom by 5, 5 divided by 5 is 1. -20 divided by 5 is -4. And so I get that x is less than -1/4. I'm going to go ahead and find -1/4 on here. It's going to be half of a half, which is right here between -1/2 and 0. Because x is less than -1/4, I'm going to go to the left. All right, let's keep on going. So very important to remember, multiply or divide by negative, you have to switch the sign. All right, next question. Let's go ahead. This one's a multiple choice question. In order to find the answer here, what I'm going to do, I'm going to actually rewrite it over here so I have a little bit more room to solve. And once again, I'm going to create that line just so I remember what I do to one side, I have to do to the other side. I'm going to go ahead and add 7 to both sides. A lot of times when you're solving an equation, the best way to solve an equation is actually reverse PEMDAS, reverse order of operations. So instead of multiplying and dividing first, you actually want to do addition and subtraction first, which is something you would normally do last. So just a nice little fun fact there. The way to kind of solve an equation is usually reverse PEMDAS. So let's go ahead and cancel this out. -7 plus 7 cancels to 0. And I'm left with 3y is greater than or equal to 24. This is 3 times y, so I'm going to divide by 3, divide by 3. 3 divided by 3 is 1y is greater than or equal to 8. And so we are going to pick this selection right here. Y is greater than or equal to 8. All right, let's keep on going. Next one. Ooh, this one's got a lot more going on. I'm going to copy it down because I want to make sure that I can show all of my steps here. Okay. All right, so the first thing I'm going to do, I'm going to create that line just so I know what I do to one side, I have to do to the other. First thing I'm going to do is I'm going to use distributive property on the left and on the right. 8 times 3g is 24g. 8 times, notice here, this is not just 2, it is a negative 2. So this is actually 8 times negative 2, which is negative 16. So be careful there. 12 times 2g is 24g, and 12 times 1 is 12. So notice here on the left and right, there are no like terms, and so I cannot combine anything. I'm going to pick a side to put g on, and I'm going to pick a side to put 16 on. Here's a little hint with inequalities. It's probably best to keep your variables on the left, just because it's best to interpret that way. We've actually kind of always got our variables on the left in order to interpret. Okay, also all of our answers here are on the left. First thing I'm going to do, I'm going to add 16 to both sides. I'm going to get 16 to the right side. 16, negative 16 plus 16 is 0, so 24g is less than or equal to 24g plus 28. I'm going to go and move the other g to the other side, so I'm going to say minus 24g minus 24g. Positive 24g minus 24g is 0 g's. So I'm going to get 0 is less than or equal to 28. Well, I don't know what world we're living in if we think that 0 is equal to 28, but the question is 0 less than 28? Well, yeah, 0 is less than 28, and so what we can actually say here is that there are infinite solutions. There are actually, every single number that I plug in here is actually going to work. And that's because at the end, I got an inequality that was always true. And so what we can say here is that all real numbers is the solution. All right, let's go ahead and move on to the next one. All right, so the next one we're going to use distributive property again. And we just want to make sure that, once again, if we ever divide or multiply by a negative, we switch the sign, which I don't think we'll do in this case. So if we use distributive property here, we're going to get 12x, not plus 6, but minus 6 from a negative 1. 3 times 4 is 12x plus 3 times 1 is 3. And once again, sorry, I forgot to put my line here. Let's remember, what we do to one side, we have to do to the other. I'm going to try to move all of my numbers to the right and my variables to the left. So I'm going to add 6 on both sides. So what I'm going to get is 12x plus 0 is greater than or equal to 12x plus 3 plus 6 is 9. I'm going to subtract 12x on both sides. And so 12x minus 12x is 0, and I get 0 is greater than or equal to 9. Well, this is not true. 0 is not greater than or equal to 9, and because I got this, I can actually say that there is no solution that's going to work in this case, because 0 is not greater than 9. All right, let's go ahead and move on to the word problems. So the word problems here, it says you save $15 a week to buy a $120 bike. Write an inequality that represents the number of weeks W you need to save to purchase the bike. Well, if we're making $15 a week, we could actually write that as 15 times W for weeks. And I want to know, okay, eventually once I get to 120, I can probably stop saving. So let's go ahead and say that I need to get anything more than 120. So minimum I need 120. Or if I got more than 120, that would be fine too. So we're going to say is greater than or equal to. My weeks times $15 has to be greater than or equal to 120. Okay. To solve this, all we're going to do is divide by 15 and divide by 15. And we should get that W is greater than or equal to, I think it's 8. 8. But we can double check that. So 120 divided by 15. 8. So if your parents give you $65 to help you buy the new bike, how does that affect your answer? Well, this is pretty obvious here. If your parents gave you $65, you wouldn't have to work more to get 120. You'd actually have to work less. So we'd say the number of weeks would be reduced. All right. Next one. So basically here we have lifeguards are needed. You need to be able to swim at least 100 yards, tread water for at least 5 minutes, and swim 10 yards or more underwater. So what we're going to do is we're just going to write inequalities for each. It says let S represent the distance in yards that you can swim. So I need to swim at least 100 yards. So what we can say is S has to be greater than or equal to 100 yards, which looks like, I'm not sure why we have negative 100 on here. We'll make that positive. S has got to be greater than or equal to 100 yards. All right, so for the next one, It says find inequality if for treading water. Well, it tells me that to tread water, I need to tread for at least 5 minutes, and we're saying T represents that. So if we're going to tread water for at least 5 minutes, we can say that T has got to be greater than or equal to 5. I don't know, once again, why these are negative. Interesting. But we're going to go ahead and fill in right here. Last one, I need to swim 10 yards or more underwater without taking a breath. In order to do this one, what we're going to do is take our variable, which I think they defined. Let's go see what they defined it as. They defined it here as U. So we're going to say U is greater than or equal to 10, which isn't even on here. Let's put 10 on here. We'll say U is greater than or equal to 10. So the last question says, you can swim 250 feet, you can tread water for 6 minutes, and you can swim at least 35 feet underwater. Am I going to make the team? Am I going to be hired? The answer is yes. You made the criteria. You just need it to be greater than 100, greater than 10, and greater than 5. So that actually does work there. All right, very last question. The maximum volume of an American white pelican's bill is about 700 cubic inches. A pelican scoops up 100 cubic inches of water. Write and solve an inequality that represents the additional volume V the pelican's bill can contain. Well, if something can contain a maximum of 700, it means it can't go over 700. So we need to make sure that we're not getting any bigger than 700. So I'm going to actually use the less than or equal to symbol here. We're going to say the volume V of the pelican is going to be this variable V. It says a pelican can scoop up to 100 cubic inches of water. Write and solve an inequality that represents the additional volume that the pelican's bill can contain. Well, right now, I know that the maximum volume is 700. If I can scoop up only 100, we want to know basically how much more can the pelican contain. We can actually add 100 to this. So basically, we can take the volume plus 100. Either way, it can't be less than 700. So the volume that the pelican can have in its mouth total, if I subtract here, is going to be V is less than 600 cubic inches. And that's the solution there. So these are all the problem types that you're going to be responsible for on the quiz for 2, 1 through 4. If you have any questions, feel free to email me or send me some sort of message. Awesome, and I hope you have an awesome day.